Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying Marine Auxiliary Systems and Tech Machinery. Today we have 12th lecture and the topic is Surface and Contact Type Heaters. In this tutorial we will first discuss about the construction and operation of oil heaters. Then we will discuss about the working principle of spray type de-superheaters. Next we will discuss about direct contact feed heaters. Then we will learn about heaters used for domestic freshwater, diesel engine cooling water and seawater heater for cargo tank cleaning on oil tankers. Lastly, we will discuss about boil-off gas heaters used for boilers on gas carriers or dual fuel diesel engines. Let's discuss these through the following slides. Oil heaters. Oil heaters are used on the ships for purification of fuel and lubricating oils. In addition to these, heavy fuel oil used in boiler furnace or in diesel engines require necessary preheating in order to bring down the oil viscosity within the desired range. Oil heaters are usually of shell and tube type, either with plain tubes or tubes with pins bonded to them. The heating medium is condensing steam with oil flowing around the tubes. The shell is supported by the mounting brackets. Two lifting lugs are provided for the transportation of oil heater. Oil enters the shell from the top at one end and leaves from the bottom at the other end. Steam entering through the central tube is supplied to the other end while exchanging its heat to the surrounding oil. A number of pin tubes return back the steam to the front end while exchanging their heat with the surrounding oil. Pins mounted to the tubes increase the surface area and also promote turbulence in the oil flowing around them. Counterflow between oil and steam further improves heat transfer rate. Tubes are attached to the tube plates on both ends, thus forming a complete tube stack which is closed by dished ends on both sides. Inner end provides free expansion of the tube stack and prevents contamination with oil. Outer end is attached to the shell by its flange and serves as condensate outlet. A steam trap equipped at the condensate outlet allows only the condensate to pass through, thereby utilizing the complete latent heat of the steam. In contrast to the coolers, heaters are equipped with a relief valve to prevent the damage to the shell, which can occur due to expansion of trapped oil if the steam valves leak. Shell is equipped with an air vent to remove trapped air before heater is put in use and with a drain valve to facilitate drainage of the oil from the shell for the maintenance of oil heater. Similarly, the shell is equipped with a thermometer at the oil outlet end for measuring the temperature. In addition, a temperature sensor may be fitted for automatic temperature control in case of fuel and lubricating oil heaters, for purifiers and auxiliary boilers, fuel oil heater. Diesel engines are usually equipped with viscosity controller instead of temperature controller. Spray type de-superheater. De-superheaters are used to remove the superheat in the steam so that nearly saturated steam can be used for auxiliary purposes. Spray type de-superheaters fall under the category of direct contact heat exchanger, and it is called external de-superheater because it is external to the boiler. A superheater is helpful in reducing the initial cost of equipment by subjecting it to lower steam temperature. It consists of a vertical cylindrical shell equipped with internal baffle from where de-superheated steam is taken out. Superheated steam is admitted in the vessel from top, which travels down through the central passage. Feed water enters the superheater from the feed water inlet on top, which is sprayed on superheated steam. A deflector at the bottom gives direction to the de-superheated steam to rise up through the cylindrical baffle around the central passage, whereas water droplets settle down. De-superheated steam is taken out from the outlet. Temperature of the de-superheated steam is sensed by the sensor of thermostatic control valve, which regulates the feed water flow to maintain the desired temperature. A drain connection is provided in the de-superheated steam outlet for removal of any water that may be carried over along with steam. A water level gauge glass is provided to monitor the level of condensate at the bottom of the cylindrical vessel. A steam trap at the bottom drains away the condensate while preventing the escape of steam from the bottom. Live steam de-superheater. The sketch shows a live steam de-superheater which is sometimes used on motor ships, especially on conventional oil tankers when inert gas plant is operated, either for topping up the cargo tanks or while starting up the cargo discharge operation when the steam demand is low and a minimum boiler load of 30% is essential for maintaining satisfactory operation of inert gas plant. For maintaining the steady boiler pressure and minimum 30% boiler load, excess steam is dumped in the vacuum condenser. As the condenser is not designed to receive live steam, water from the condensate pump is sprayed into the live steam to reduce its temperature. Temperature controller senses the steam temperature before condenser and regulates the flow of spray water through control valve to maintain desired temperature. Direct contact feed heater. The sketch shows a direct contact feed heater in association with de-aerator, which is used in modern steam turbine plants. De-aerating feed tank is located high above in the engine room so that main feed pump does not suffer from cavitation due to high temperature of feed water. Condensate is sprayed from top of the de-aerating section, which consists of series of trays for increasing the surface area. Extracted steam from the turbine is called blade steam, which is mainly utilized for heating purposes. Blade stream supplied to the de-aerator intermixes with sprayed water, which helps in separating the air dissolved in water. Air liberated from the water is released to atmosphere from the top. Blade steam is also used for heating the feed water in de-aerating feed tank. Main feed pump draws de-aerated and heated water for the supply in boiler. Fresh water, jacket water or tank cleaning heater. The sketch shows a two-part shell and tube type heat exchanger used for heating domestic fresh water, diesel engine cooling water or seawater for cleaning of cargo tank on oil tankers. The heat exchanger consists of a cylindrical shell. A number of tubes attached to the tube plates form the tube nest, which is secured to the shell on both ends. In a long heater, tubes may be additionally supported to prevent their sagging. Shell is closed by end covers on both sides, one of which is free and the other end contains water inlet and outlet connections. The heater shell is secured to the base plate. Water is admitted through the inlet connection, passes through the lower tube bank, direction is changed at the free end and passes through the upper tube bank where it is discharged from the outlet connection. Steam enters the shell from the top and surrounds the tubes to transfer its heat to the water flowing through the tubes. Flow of steam is regulated by a temperature control valve depending on the water outlet temperature. A steam trap equipped at the condensate outlet prevents any release of the steam so that heat of the steam is fully utilized. A relief valve is equipped on the shell to protect it from high steam pressure should the steam pressure controller malfunction. Shell is equipped with a drain connection for the maintenance purpose. Boil of gas heater. The sketch shows a single pass shell and tube type boil of gas heater which is used on motor vessels using dual fuel diesel engine. LNG fuel is stored at minus 162 degrees centigrade. The boil off or vaporized gas is heated to temperature of 30 to 45 degrees centigrade before admitting in the engine cylinder. The heater consists of cylindrical shell with flanges on both sides. A number of tubes are attached to the tube plates which are bolted to the shell flanges. A number of baffles are provided to direct the flow of heating liquid which also support the tubes. Tube ends are closed on both sides by the end covers. Heating medium is a mixture of water and ethylene glycol with the required density which acts as antifreeze and prevents rupture of the shell. Glycol is first heated with the steam as discussed in the last slide. It enters the heater from the inlet connection, circulates around the tubes and leaves from the outlet connection. Circulation of glycol is maintained before admitting the boil of gas, otherwise glycol can also freeze and cause rupture of the shell. Boil of gas enters the inlet and cover, passes through the tubes and leaves through the outlet connection. A drain connection is provided at the bottom of the shell for the maintenance purpose. This completes the study of surface and contact type heaters. This book is written by me and covers all the topics as per the syllabus specified by Indian Maritime University. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exam and also to work on ship's auxiliary systems and deck machinery safely. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You must subscribe to the channel for getting notification about the new tutorials. I will be back with a new lecture shortly. Thanks for watching till the end.